But just today, I'll just give you some background on the early mapping efforts that have taken place in the Coral Sea Marine Park. All right, so just some context over where we are and what I guess the geography here. So the Coral Sea Marine Park itself is nearly 1 million square kilometres. It was declared in 2017 by the Australian government as part of a network of marine reserves, offshore marine reserves around Australia. It is one of the largest marine reserve networks anywhere in the world, and of the Australia's marine reserves, this one, the Coral Sea Marine Park, is the biggest by far. I think America's probably got, the USA's got the biggest marine park, but this is probably like number 1 or 2, just number 2 or 3, just down on the list. So on the left-hand side, of course, you're getting familiar with it. You're on the Coral Sea, Queensland Plateau. Now, as an area, it's quite diverse. It stretches along. It lies adjacent to the Great Barrier Reef Marine Park. So it has these zones in it. Now, the zones have been contentious, and over the years, there's been a lot of discussion about it. When the park was first, the reserve was first put up, there was a lot of public pressure around fishing and resource collection and the like. There is no oil drilling or exploration anywhere within the marine park, but there is still commercial fishing, generally tuna, longline fishing, I think some seine net fishing, but it's fairly limited, and it's really to supply domestic market in Australia. Those big green areas are green zones. They're no-take areas. So you can visit, and as we've already done, around Osprey Reef has a big green zone, but it's a no-take zone. And so this marine reserve has varying levels of protection. It stretches a long way from the Queensland coastline. So 60 kilometres is about the closest it gets, and that's up around Cooktown. Sort of opposite Osprey Reef, in anything up to 1,100 kilometres from the Queensland coastline. So it's not an area that's visited very often, maybe by the odd sports fishermen. Certainly dive adventure tourism happens up around Osprey Reef. We've talked about that earlier. But and then the occasional fishing vessel. Of course, the defence gets out there. There has been incursions of foreign fishing into these waters, but overall, it's not visited very much. And certainly, I don't think there's any other research vessels out there except yourselves. So, other geography, 37 reefs, of which about 30 of those are on the Queensland Plateau, the focus of this expedition. There's automatic weather stations on 8 reefs. There's lighthouses on 5, and it's inhabited by only 1 K at Willis Island, and you will be going past it. It'd be very good if you could call out and say hello to the 2 or 3 meteorological people who have been stationed there around about 6 months of the year in rotation. That station has been there since I think the 1920s, and set up as an early warning station for cyclones, because you are definitely in cyclone country. But we're not expecting cyclones through May or any time that you're going to be out there. That would have all happened during our summer season. Okay, so our really earliest mapping history, apart from the people who bumped into reefs, and we'll talk about that in a moment, really comes back to Sir Henry Mangles Denham, HM Denham. So he lived a long, productive life. He retired as a rear admiral, but he mainly sailed on HMS Herald, which had lots of experience. It was a very old ship before he even got hold of it. It had been doing surveys and all kinds of Navy things around Canada and around the British Isles, of course. But he embarked on it and I think it was the early 1850s to what was in the South Pacific. And his role as a surveyor was to go out and survey all of these these islands scattered across the South Pacific. So he really focused his efforts in Fiji, Vanuatu, New Zealand, and Australian waters. So the Herald itself was wooden, it was sail only. It was all done by sextant, their old ways. Any depth sounding was all done by leadline. Pretty hard task, if you imagine, but he did 3 journeys to the Coral Sea area between 1858 and 1860. And his charts, in fact, are still used up to present day, mainly to do with actually delineating where the edges of the reefs were. Of course, we now have LiDAR and satellite imagery to improve those charted reef edges. But the aim was to find out where the hazards were, and he did some extensive surveying in the Queensland Plateau and the Coral Sea, and a lot of the reefs that you are now mapping around are named by Sir Henry Denham, including Herald Surprise, which you're going to map around in the next 3 days. So that reef that small reef that's to the northeast of the larger Flinders reef that you're actually on at the moment is named after his vessel. Okay, some early shipwrecks. Probably the most important one of all was that experienced by Captain Matthew Flinders. So in Australia, there are some early explorers that really are very much in people's minds. Probably the most notable is James Cook, Lieutenant James Cook, who was out here in 1770. This year is the 250th anniversary of the discovering of east coast of Australia, and certainly the mapping of east coast of Australia. And if I just may, Captain Cook did end up going out a little bit of the Coral Sea, although he spent most of his time during 1770 mapping the east coast and staying on the continental shelf waters. It wasn't until about mid-1770 where he came to grief on Endeavour Reef, which is north of Cairns, where he ended up having to pull the vessel into Cooktown, as it is now called. After repairing the Endeavour, he pushed out into the Coral Sea. So he pushed out into just opposite Osprey Reef, where you were just a few days ago, and then continued northwards. So we might be able to talk a little bit more about that at another talk. But right now, I just want to talk about Captain Matthew Flinders. He's the other great explorer of Australia in that 1700s period. He did 3 voyages out to Australia. The most notable was on the Investigator, HMS Investigator, again sail-powered, and he was the first person to completely map, do the full circumnavigation of Australia. So prior to that, all explorers had basically only done bits and pieces, including Captain Cook himself. But Matthew Flinders was the first person to sail all the way around Australia, and he was the one who came up with the name of calling Australia, Australia. Prior to that, it was called New South Wales or New Holland or Van Diemen's Land, parts of it like that, but he was the one called Australia. And having done all of that wonderful mapping, he gathered up all of his charts and all of his journals and boarded the HMS Porpoise and Cato with the rest of his crew and another vessel, and they were going to sail back to England so that it would all be published there. So they left Sydney, sailed northwards, and the idea was to come up out in the Coral Sea and then go out around through Torres Strait and all the way back to England. It's months worth of voyaging. Well, in the middle of the night, they came to grief on what is now known as wreck reefs. HMS Porpoise and Cato were shipwrecked. You can see a drawing of that. 3 or 4 people drowned in that. But there are a number of sand cays on what we call wreck reef now. And the survivors, including Matthew Flinders, managed to pull out one of the small cutters, like a lifeboat, and they rowed all the way back to Sydney with some of the survivors. So you imagine rowing for, it would have been a couple of 1,000 kilometres. They managed to find some rescue vessels. They sailed back grab whatever survivors they could who'd been on there for weeks, living off birds and whatever water they could find, making very rudimentary shelter. And then they decided, some of them decided, okay, we will continue sailing. Some of them went off to China and managed to get other vessels back to England. Matthew Flinders wanted to go to England, of course. He continued sailing through Torres Strait and ended up being captured by the French in Mauritius, because the French at that France and England decided that they were going to have another war, and he was thrown into prison for many years. The French confiscated all of his charts, and he ended up having to write his journal from within prison in Mauritius. I guess the postscript to all this is he was eventually released by the French. He ended up in England. He continued writing his journals, but died before they were published. But now we have the wreck reefs named after this famous shipwreck. Okay, let's talk to more recent shipwrecks, recent being within the last 70, 80 years. I want to talk briefly about the Battle of the Coral Sea, because I would like to give a talk about this later in the voyage, focusing directly on this. So the Battle of the Coral Sea, the World War II Battle of the Coral Sea, was fought between about 4th and 8th of May 1942. It was a very important battle from the perspective of Australia. In early 1942, the Japanese had taken over much of Papua New Guinea, the Malay Peninsula. They'd already invaded Hong Kong. They had swept right through Southeast Asia. Things were looking very dire for Australia. Certainly by that time, the raid at Pearl Harbor had happened, and there was a very real risk that Australia, as one of America's allies, was going to be cut off. So Japan had already raided into east of Papua New Guinea, and at the beginning of May, they had a base in Rabaul in Papua New Guinea, and they were mobilizing a very large infantry force through transports to come in and take over Port Moresby, which is the capital of Papua New Guinea. From there, they were going to be able to do raids into Australia. Because of code breaking, the Americans had wind that there was this fairly large convoy group coming through, and a series of battles were fought between both Australian and American forces in the Coral Sea, so at the very northeastern end of the Coral Sea, which resulted in the USS Lexington, the Neosho, and the Sims being sunk. The Lexington was discovered by the RV Falkor, which is Paul Allen's vessel, in, I think, March 2019. And I was the principal investigator to lead a mapping expedition on the RV Investigator on the 16th of August 2019. We wanted to map and do the best we could to map the area of the USS Neosho and Lexington, and we believe we found the likely sinking position of the Neosho, but I'll leave that to another talk. Okay, so back to the Coral Sea. The only real mapping that has been done here, modern mapping, has been done with LiDAR mapping. With the Royal Australian Navy, the LADS, Laser Airborne Depth Sounder. Now, the Royal Australian Navy was one of the very earliest proponents of LiDAR bathymetry, and this LADS system has been operating for at least 2 decades now. And of course, there's LiDAR mapping. LiDAR bathymetric mapping is in widespread use around the world. But LADS was the very, very earliest system. It's now several versions forward, and we could talk about that. But it's a remarkable system. And in a previous life, I was a Navy hydrographic surveyor, and I've been directly involved with this system. So just some simple stats. Some specs. It flies anywhere between sort of 1,000 to 1,500 feet. It generates about 240 metre wide swath. It's 1,000 plus soundings a second. So it's really, really great for surveying these shallow waters. The early LADS 1, which came online in about 1993, was sort of operational then, was only about 25 metre point spacing. So not great, not by today's standards. Now we have LADS 2 and LADS HD, and we're doing, it's a really a deep water system. It's not a shallow, it's not for really working in those swash zones, between land water interface. There's much better systems now, but LADS 2, you're getting points. LADS HD, you're getting point spacing between 2 and 6 meters, depending on their height above the sea surface. And we can get a maximum depth down to about 70 meters because it's a very powerful system. It's one of the deepest airborne LiDAR bathymetry systems in the world. And out here in the Coral Sea, where the waters are very clear, we have got depths down to 70 meters, which is pretty remarkable. Okay, so from here on, I just want to take you through some maps that have been collected by the lads out in the Coral Sea. I've also put a folder where these maps have been placed as Google Earth KMZ files. So I welcome you to use them. Please don't pass them on to any third parties. And of course, they're not to be used for navigation, but they will help guide and plan the surveying over the next few weeks. Okay, so Osprey, Shark, and Vema reefs. We've already been around this. Osprey Reef, really quite a beautiful reef to look at in 3D mapping. It's about 30 kilometres long. It's got this big lagoon down about 30, 40 metres, real bathtub shape. And there's this thing at the sort of northwestern end. It's called the entrance. You can actually steam in and out. The dates I've put there are dates when it was surveyed. So these early 1990 kind of dates, these are old LADS 1. So point spacing is never better than 25 meters. So it's quite coarse. We transitioned to LADS 2 in 2009, and you'll see the difference in the quality of the bathymetry definitely improved from then. So Bougainville Reef, just a small lagoon. You've been around that already. Holmes Reef, where we've been for the last few days. Again, this is old LADS 1. It's only 25 metre point spacing, but it still gives a fairly reasonable picture of what the shallow lagoons look like. And, we've been looking at the deep drainage coming out of that western lagoon. And you can see where most of the drainage is focused in the centre. But that's quite interesting because, in fact, the lagoon is at the very northern end, and there's quite a distinct channel that where any water or perhaps sediments. I think the East Holmes Reef is quite pretty too. Flora, you've done a slingshot around that a couple of times now. And McDermott Reef, you were there last night. There's not much to it. There's not a lot above sea, down to around 40, 50 meters. But it's old LADS 1 data. Not much of a picture. It'd be interesting to see what you got from McDermott Reef and the depths. Okay, here we are at Flinders Reefs. This is really high density data. This is LADS 2. It was only collected about 2 years ago. It's really good shape. And of course, Flinders, both the Flinders Reefs and the north and the south have this sort of classic atoll shape. Deep lagoon to well over, I think, over 60 meters deep. Lots and lots of pinnacles inside. Yes, it'd be safe to navigate within them, but you can see it's quite interesting. The South Flinders Reef is almost fully enclosed by a shallow reef flat around it. But again, like scientifically, very, very interesting. There's two reefs to the north. I mentioned Herald Surprise. The one at the very northern end is Herald Surprise, named after HMS Herald, and you've just been around Dart Reef. This unnamed 5-meter reef, again, high definition. This is just to the east of the Flinders Reefs, and you'll go there probably from Monday or Tuesday next week. There's no lagoon. It's just shallow reef up into the very crest, dropping away to the edges. So you may find it's surprising that there are unnamed reefs. There's a bunch of them here in the Coral Sea. You're going to survey around several of them. It's really up to us if we want to give them a name, because nobody else is doing it. They're just kind of not on anyone's naming radar, but there is a process in place to be able to do this, and it'd be nice to give one name like Falkor Reef or something like that. Okay, Herald Cays, again, you'll be visiting this within the next week for sure. In the history of marine parks, in the Coral Sea Marine Park, the Herald Cays was the first place that was ever named a marine zone. This is before the Coral Sea Marine Park was named. It's got 2 shallow sand cays on it, covered in birds and turtles and the like. So way back, decades, this was the first one that was ever made a marine park. And then since 2017, it expanded to a much bigger area. The Moor Reefs sit over sort of northwest of the Diane Banks. This is going to be an interesting area. On the seafloor, there seems to be lots and lots of pinnacles down in the depths, but here are 3 small reefs that come up to the surface. This was the first place, when I was in the Navy, we mapped these for the first time in 2009 when I was working at the LADS flight unit with the Navy, which is based out of Cairns, I might add. Okay, Diane Bank, very big area. You're going to need at least 3 days to work in this. I mean, that reef itself is at least 30, maybe 40 kilometres long, and the Willis Islands to the south, also big. If we were going to spend any more time at sea, you're probably going to need those days to work on this area. Now, just looking at the Willis Islets on the right-hand side, you can see the red is the shallow reef area. The very southernmost one is sort of this elongate red reef. That's where Willis Island Meteorological Station is. And you can get quite close to it. I visited it in the 1990s when I was a hydrographic surveyor with the Navy on a ship. And we did lots of scuba diving around it, and the people are very friendly. They don't get too many visitors, mainly visiting yachties and the like. So it'd be good if you could sing out and say hello, let them know what you're doing. But again, 2 very, very large atolls. Old Lads 1 data, so the point spacing density is not so great. Don't have a real clear picture of the lagoon, but this is just the best we can get for that older system. Moving southwards, we're into the Coringa Islets, Magdelaine Cays. I guess when the first mapping was done, people were more focused where the reefs were. They weren't so much, they didn't realise that these reefs were actually on top of very large banks. So it's only with sort of modern echo sounder technology did we realise that the Coringa Islets and the Magdelaine Cays are actually all part of the same giant bank. And again, we don't have a real clear picture of what the lagoon looks like. It's probably down around 60 metres. The newer LADS 2 data would probably be able to map it, but this old LADS 1 data, we weren't able to fully get down to the lagoon. Again, another unnamed 17-metre reef, mapped with high density data, good LADS 2 data. It's sitting there. It's also after a name. The Diamond Islets, Tregrosse Reefs, only mapped just a couple of years ago. Huge atoll. Again, you can see lots and lots of pinnacles sticking up in the bottom, and the LADS 2 data can actually push down a lot deeper, down to around 60 metres depth. It's the only place in the whole Queensland plateau that has any multi-beam data along it. You can kind of see that complex rugosity. And this is because the old Southern Surveyor had done a few transits from Fiji in towards Cairns and Townsville, and they were able to map just along the flanks. So this is our only hint that the flanks of these reefs on the Queensland Plateau have any kind of complexity. And so, of course, what you're doing now is revealing so much more, but it's sort of adding to that story. And then Lihao Reef is, again, really large. It's nearly 100 kilometres long. It's going to take quite a few days to really do justice to mapping around the edges of this. But again, a classic atoll. I've said this a few times now. It's both the Diamond Islets, Tregrosse Reefs, and Lihao Reef are in the top 20 largest atolls anywhere in the world. And we have the privilege of the Falkor going and visiting these to try and help us understand what the deeper seafloor looks like around them. Again, just to wrap it up, the last two small reefs, which is part of this Queensland Plateau expedition, Abington Reef, it's very shallow, right across the surface, and then Malay Reef. So you'll probably be looking to do that closer to the end of the expedition. And just to kind of finish up the whole story, wreck reefs and Cato Reef are not on the Queensland Plateau, but I've added them here. If only Flinders had this kind of map before he ran aground. So the wreck reefs, of course, is named after where Flinders on the Porpoise and Cato ran aground and were marooned. There's at least 3 cays, sand cays, West Cay, Bird Cay, I forget what the central cay is, where the survivors marooned. This was mapped. All of the reefs on the Tasmantid seamounts were mapped in 2019. And I was part of an expedition on the Investigator last year to go and map the flanks of these. So we have nice multi-beam maps around them. I've included these maps, these LiDAR overlays in that folder for you to have a look at. These reefs are growing on extinct volcanic seamounts. So they have a base of volcanoes. Extinct now, probably around 40, 50 million years old. And Cato Reef, which is part of that stretch of the Tasmanian seamounts, is of course named after the Cato, which is one of the ships shipwrecked. Okay, this is the last slide, just to show you how we're actually using some of this data. So the Navy has collected the data mainly for safety and navigation purposes, but we can take this data, this bathymetry data, and we have a honours project running with University of Sydney, with Jodie Webster, who's a principal investigator as part of this expedition. We can take that data and we start doing some clever spatial analysis with it. So if Debs is watching, she'd be very familiar with all this. You can start doing slope analysis, which brings out where those sloping features are. Sloping features, not surprisingly, tend to be where we find more marine benthos, marine biota attached to. Steep is useful because the sand doesn't accumulate. We can get bare rock and we can find in the mesophotic zone, this is where lots of coral and sessile marine creatures live. So slope analysis is very easy to do in geographic information systems, and it can bring out where those steeper areas are. We can also do things like rugosity, which is like almost standard deviation of the seafloor. If you can imagine a window moving over the pixels of the bathymetry, if it's very flat, the neighboring pixels to the center pixel is similar, and so standard deviation is very low. Where you get lots of rugosity, if neighboring pixels vary greatly compared to the center pixel, you get higher rugosity or higher standard deviation. Again, it tells us something about what the topography of the seafloor is like. And we can do what's called benthic terrain modeler, and it pulls out all kinds of features, the crests of features, the depressions, the flat areas, and the slope. And so this can be done very easily in GIS. The idea being that we can actually match the topography to the biology. So the maps you're creating are very useful. We will be doing exactly the same thing on the bathymetry data you're collecting around the flanks. We can find out where the finer channels are. We can do spatial analysis to really bring out that fine scale topography. And the one on the right is an interesting one. One of my one of my jobs is to work with Geoscience Australia, maritime boundaries people. They're particularly interested in knowing where the low water lines are on these reefs. Now, just like in America, we have maritime zones and they all have to be measured from somewhere. And the baseline in Australia is lowest astronomical tide. So I can take these bathymetry surfaces and automatically generate contour lines, but importantly to extract out the lowest astronomical tide. Here it's just called low water line. And from that will then is what's called the baseline from which all maritime zones are measured. So territorial seas, which are 12 nautical mile, are measured from those red polygons that I've highlighted in the shallow waters. Territorial sea boundaries and also exclusive economic zones. Now, this is all under the UNCLOS 1982 rules that all nations that have ratified the UNCLOS agreement agree to, and there's lots of rules around how you generate these different zones. But it has to start with understanding where, in Australia anyway, where that low water line is, and we use these digital elevation models to generate them. And that concludes my talk. So I'll stop sharing there and throw it to the audience for any questions. And thanks very much.
Thanks, Rob.
Thank you.
Does anybody have any questions?
How deep does LiDAR data go into the sea surface?
Yeah, it's all about clarity, what your turbidity is. And the kind of general rule of thumb is, I don't know if you've come across a Secchi disc. It's a round disc with black and white circles, quite large, and you just lower it on a line, and depending on the turbidity, at where those black and white disc disappears, that's your Secchi disc depth, and that's just looked at down from the surface with Mark 1 eyeball visual. LiDAR typically can do twice that depth, so it's all about the clarity. Out here in the Coral Sea, we've got LiDAR data down to around 70 meters depth. But of course, when you get into those shallower zones near the coastline, where mud and turbidity, sediment and the water column make it really difficult, then LiDAR struggles. Again, it's trying to work at perhaps 2 times water depth. But if you're in murky water that maybe 3, Secchi depth of 3 meters, you may only get 6 meters out of that. So the way people are working with LiDAR now is they have multiple LiDAR systems. Now, I know, Debs, you've got a hydrographic background. I'm not sure if you've worked much with LiDAR, but what's happening now, aircraft are flying with at least 2 systems. A shallow water zone, which is very, very high frequency lasers, perhaps only pushing down to maybe 10 meters depth, but very, very high rate. And they're also able to map the terrestrial side, like the land side. So you're getting terrestrial LiDAR pushing down into the shallow zone, and then you bring in the big guns, the LAD systems. They're very, very high power, but are not so good in the shallow water zone. So you're getting complementary LAD systems. Not one system can do it all. So they're flying with both, and they're typically taking aerial imagery at the same time. So this is typically how people are mapping these coastal zones.
Great, thank you.
Did you get to fly on the aircraft?
Yeah, I did. So the early lads was in an old Fokker Friendship. I don't know if you heard of the old Fokkers. They're a huge plane. They needed special fuel and the like. In Australia, I remember flying on them, in the 80s, but the Navy had them up until 2009, and then they replaced them with the Dash 8. Now, sadly, the Navy LAD system is no longer running. It finished late last year because it was almost job done. What's happened now is the Navy have given all of that LiDAR flying to civilian organisations like Fugro and the like. Fugro has partnered with LADS. In fact, it was always called Fugro LADS. So as a private organisation, they helped develop LADS. So they were one of the very early runners, but they're still doing mapping with their own LAD system. But why they killed the program, partly why they killed the program, was those aircraft are expensive to run. A Dash 8, you know, you could put 20 people on them. And as the systems have got smaller and smaller, but the aircraft have stayed larger, they're just expensive to operate. And so now that whole LAD system can be flown, you know, in a small lawnmower size aircraft to do the same thing. It's just cheaper to run. And so the Navy LADS program has run its course, and we had a final farewell in November last year, of which I was a keynote speaker to, I guess, talk about the legacy and how the data has been used. But I think it's been a very, very successful program that's been running since 1993. The data that I've provided in that folder, Debs, is some of that. You know, it stretches back 2 decades. And the Navy understands how well it's been used for scientific and maritime boundaries purposes beyond the original, you know, safety of navigation that it was originally planned for. So the data will live on and will be used for many more purposes, which I guess brings me to what you're doing. You are doing the first real multi-beam data in there. And we're now a lot more comfortable, of course, with collect once, use many times, and so your data will be as well. So we're very, very grateful on shore for the work you're doing. But what you're doing is extremely pioneering. Like, it's where you're going now over the next few weeks. No one's been there with a multi-beam before, so we really have no idea what's down there.
Cool.
Okay, might leave it at that, eh?
Yeah.
Brilliant.
Thanks so much, Rob. Really appreciate it.
Yeah, thank you.
Yeah.
All right.